jump into the lesson, I have a quick bonus question for all of you. So don't say the answer out loud, just think it in your head. So with an ionic compound, like we did last time, let's say for example, magnesium chloride. So this is its name. And then this is its formula, MgCl2. So my question to you is, why does the name not say anything about that number 2? Or another way you think about it is, how do I know that number 2 belongs there? So think in your head for a second. Okay, turn to a table buddy or someone nearish by and share with them what you think. Ready? Go.
Always two.
Why do you guys think that?
Okay, yeah. Yeah.
Okay, Jerem, I heard your answer, so I'm going to pick on you because it was a good one. It's okay, you're going to get smiley face for it. So share with us what you said about why we don't need, why the 2 is there, or why it's not necessary in the name.
It's not necessary because you know you need 2 chlorines along with magnesium because it only has room for 1 more valence electron, and magnesium has 2 electrons, 2 valence electrons, and so it's just math. Like, you don't need to put an extra 2 because we can just figure that out.
Good, right? So it's all about, we know with ionics, it's all about that balancing. Is there any other way to balance Mg and Cl? No, right? Not to make them both happy. So like, would this does this compound exist? No, right? That doesn't exist. This doesn't exist. Those aren't real things in the world. They don't exist because they don't balance. So with ionics, there's only one way to make the molecules balance when it's a give and take relationship. The difference is today with covalent, what happens at the molecular level in a covalent bond? They're sharing. There are a lot of ways 2 things can share and still be balanced or full. So the difference with our naming systems, and this is the hardest thing of this unit, is making sure you recognize there are 2 sets of rules here. There are rules for ionics, there are rules for covalents. Don't blend them. Otherwise you get all sorts of weird compounds that aren't things. Okay? Keep them separate and it makes it a lot simpler. Jerem, by the way, have 2 smiley faces for sharing. If you said something along what he said, you can give yourself 1 smiley face. Okay? So with the covalents, okay, we have this prefix system that helps us identify how many of each thing there are, because it's not based on charges at all. Okay, so these are the rules, and then we'll do a bunch of examples. Okay, so similar to before, you name the first element. Okay, so keep them in the order that it's written. We do have the same thing where we end it in "ide", so that is the same. But the difference is we're going to add a prefix to indicate how many of each element we have. Can someone remind us really quick for when we start doing the mixed practice? How do I, looking at a formula, how do I identify if something is ionic or covalent? Yeah, how do I do that, Jeremy?
Covalent is a non-metal with a non-metal, and then ionic is non-metal with a non-metal.
Perfect. So that's kind of what you're going to want to do first. Like, today's all covalent, but when you do the mixed homework assignment, the first thing you've got to say is, okay, is this ionic or is it covalent? Because that changes the rules that you use, right? Okay, so this is our prefix system. This would be something I'd highly recommend writing down on a note card. Some of them are pretty logical, so they're kind of easy to memorize, but okay, so if you only have one of something, it's already on there, but we use the prefix of mono. So for example, you may have heard of something known as carbon monoxide. That mono means there's only one oxygen in that compound. Okay, if you have two of something, we use the prefix of di, di. 3 is tri. And some of these once again should be familiar with other words. What's a word that starts with tri and has 3? Tricycle, triangle, tripod. Okay. 4. Now, there's other prefixes for numbers, by the way, such as bi means 2 as well, but it's not the one we use in chemistry. That's why we call them bicycles. Technically, you could also call them dicicles and it'd still be correct. But the prefix for 4 that we use in chemistry is tetra. Now, if you're a Tetris fan, that can help you remember because all the blocks that fall down in Tetris are made up of 4 small blocks. Does that make sense? If you know what Tetris is. All the different shapes are made up of 4 things, okay? 5 is penta, like a pentagon. 6 is, any guesses? Hexa, like a hexagon. 7 is hepta. And there is such a thing as a heptagon. There's no one uses them. It's a 7-sided shape. 8 is octa, like an octagon or an octopus. Right, octa for 8. 9 is nona. And 10 is deca. And that's as high as we're going to go in this class. Okay, so let's try a problem here and see how it works. Okay, so we're going to do that first one up at the top. Now, the one thing that I would write a note of up by the rules, because I can't remember if we put it on there. Oh, it is on there, but I would underline. Let me go back to it so you can emphasize it. Okay, put a big star by this. We don't use the prefix mono ever on the first element. If you only have one of the first element, you just write its name. You only use mono on the second element if there's one of them. Okay? Okay, so for example, on this molecule, so we have CCl4. So C is what element? Carbon. So write down carbon. Now because it's the first element and because there's only one of them, we just write carbon. Okay? Alright, second element is Cl, which is chlorine. Now this is where we're going to add the prefix and change the ending. So what's the prefix for 4? Tetra. So we're going to do carbon and then tetra, chlor, and then change the ending to ide. Carbon tetrachloride is its name. Okay, so the tetra is there because of the 4 in the formula, and then the ending always goes to IDE for covalence. The way I kind of think of it is it's like the molecule is now like them being bonded is them like getting married, and so the girl is changing her last name. So that's why it goes to ide. Okay, all right, let's try another one. So N2O, so N is nitrogen, prefix for 2 is di, so we're going to write dinitrogen. And notice, I know these words are weird, but they are all one word. It's not like 2 separate things. Okay? O is oxygen. I have one of them, so the prefix is mono. Now with the prefixes, if 2 vowels come together, Like in this one, if I technically wrote mono and oxygen, you'd have N, like two O's side by side. You drop one of the vowels. There's one case where you keep it, and I'll show you that because it kind of loses its meaning if you don't, but this is just monoxide. But in terms of the spelling, once again, on the test, you don't actually are going to have to spell any of these yourself. Because I know that can sometimes be the hardest part. So as long as you have the right beginning, and you change the ending to I, if you kind of messed up the middle part, it's okay. The more you do, you'll kind of get better at it. So, okay, try this one for a smiley face on your own. Fill that one in on your paper for me. Set your pencil down when you're done. Okay, everyone, pick up your pencil in your hand. Now, the funnest way to say covalent is you say them like you're casting a spell, because that's how they sound. So on the count of 3, you're all going to wave your wand and say your answer. Ready? 1, 2, 3.
Sulfur hexafluoride.
Yeah, very good. So if you said sulfur hexafluoride, you are correct. You can have a smiley face. Very good. Questions on writing names from a covalent formula. Pretty straightforward so far. Okay. Sulfur hexafluoride. Okay, let's do the reverse. So if you're given a name and we have to write the formula, it's just as straightforward. There's no crisscrossing, there's no switching, there's no balancing. The prefix just tells you how many you have. So on this first one up here, arsenic, what's the symbol for arsenic? AS. Okay, it doesn't have a prefix, so that just means there's one of them. Tri is the prefix for 3, so it would be ASCl3, and you're done. Okay, try these two for 2 more smiley faces. Hopefully the hardest part of covalent is remembering symbols and the prefixes, but the actual putting it together isn't too bad. Set your pencil on your paper for me when you're done. That, you can have one smiley face. Once again, so we're just changing prefix to a number. And then for this one, you should have P4O10. Any questions? It worked out nicely that this was our lesson on a short day. Okay, go ahead and go to your homework packet and let's practice it. So your homework for tonight is the next page in the packet called Covalent Nomenclature, front and back side. But it should be pretty quick. Go right in there, Tyler. Okay, I'll walk around. Let me know if you need any help. Feel free to talk to each other and work together even though you're spaced out. Also, by the way, there are answers to this posted on the website, so after you do it, before you upload it, make sure you're doing it correctly.